Now, looking back a little further into your career, you obtained a PhD in systems engineering from George Washington University there in DC. And so, first of all, tell us what systems engineering is. I think we can pull up into our heads relatively easy if somebody says chemical engineering or software engineering or material engineering. You can probably get a pretty good idea of like, okay, we're making software, we're making some kind of chemical, or designing a chemical process to create a chemical. Uh, it's it seems relatively straightforward to imagine what the person is doing. What does a systems engineer do? What does that mean to be a systems engineer?
So a systems engineer has the full life cycle perspective and understanding. Remember when I talked about integrating the NIST AI framework and MITRE ATLAS in order to manage and cover the practices from initial design through development, deployment, ongoing maintenance, and disposal? That encompasses systems engineering, being able to work across that life cycle, incorporating security management, risk management, program management, all within that to ensure you're delivering products on time and on budget. That's the systems engineering life cycle. And I got my
Nice.
PhD in systems engineering. Specifically, I developed a AI model in 2016 that looked at project failures and why projects failed, and developed it with small data set. We're not talking large language models here. 250 data points across the software development industry, looking at failed projects as well as successful project, created that predictive analytics model, leveraging R programming to be able to show why projects fail and the likelihood of occurrence of failure, and then developing the mitigation strategies to allow projects to really get back on track. And some of the major failure points was when projects, you know, go off schedule, or they eat up their budget, or they go off budget, or insufficient knowledge and understanding of the product or the systems that's being built by the development team, stakeholder support, executive stakeholder support, or the lack thereof. Some of those things cause projects to fail.
Nice. And so that does give me a pretty good sense of what systems engineering is. And it's something that's always seemed very prestigious in my mind because I grew up, um, I went to high school at least in Waterloo, Ontario, Canada, which has the University of Waterloo, which is one of the world's top engineering schools. And I remember when I was graduating high school, the program at the University of Waterloo that had the most difficult entry criteria, that was the most in demand, was systems engineering. And so I have it on a pedestal in my head of being this extremely prestigious, challenging, and rewarding area of engineering. Now, since finishing your PhD about a decade ago, nearly a decade ago, at GW University, since then you've been adjunct faculty as well as a doctoral research advisor at George Washington University. So you probably have some good insights into why people. So let's say a listener out there who's interested in AI, they could be a data scientist, ML engineer, software developer, maybe a product manager. But amongst our listeners out there, why should someone perhaps consider doing a PhD, maybe even specifically a systems engineering PhD? How would that be helpful to them?
I think it was helpful. So I achieved my PhD when I was hired by MITRE in 2011, I believe. Onboarding, they were like, yes, we pay for 100% tuition reimbursement. And I was like, oh, this is pretty amazing, considering I'm sitting on student debt currently. But I was like, okay, what am I going to study? Well, when I entered MITRE, my title was systems engineer. And I thought, oh, okay. Then I received a postcard in the mail from GW that says, we are kicking off our program for PhD in systems engineering. And I was like, oh, this is great. I applied, I got in, and here we are. The rest is history. And so what my advisors did for me GW asked and said, hey, we'd love for you to come in and be an adjunct as well as be a doctoral research advisor. So I've been able to do that and supported 21 students in attaining their doctorates in systems engineering at GW as well. And that's really been super rewarding because not only, it's that constant learning. I learn from my students because these are folks who are, experienced. They're already in the working field, and they want to attain their PhD to be able to support them in advancing the mission of their organization or advancing their personal goals. And that's the reason why I got my PhD is to advance my personal goals as well as support MITRE in some of their mission that they were driving for the federal government.
Amazing. When you say personal goals, do you mean that you use your systems engineering education in your personal life to kind of engineer? Is that what you mean?
Yes. So I always wanted a PhD, so that was my personal goal.
Right, right, right.
And the universe, I believe in the universe, gives you what you need when you need it. And I received what I needed at the time at MITRE, and now it's supporting me in AI and supporting
Mhm,
smaller companies and understanding that, they have to really lay out their framework. Do they have the right set of skills? Do they have the right developers? Do they have these developers have the skill set to be able to build out their capabilities? Did they do the design? Do they understand their design and what it is that they're building? And what does their roadmap look like in the next 3 to 5 years? And who is their market segment that they want to go after? And how do they plan to deploy it? And is ongoing maintenance a part of their life cycle processes? So yes, I use it personally for these smaller companies. I use it for myself. I do talks and I present at conferences, and it's helped me to be a really good researcher and to really take on different perspectives to bring together a specific topic.